My name is Aryaan Swain, and I will be discussing QUIC and HTTP3, which represent a modern evolution of transport and application layer communication on the internet. So, in our syllabus, we study about TCP and UDP, congestion control, flow control, and application protocols like HTTP. However, traditional TCP-based communication faces several performance limitations in today's high-latency mobile and cloud-based networks. So to overcome these limitations, a new transport protocol called QUIC, which was developed by Google, was introduced, and it later became the foundation for HTTP3. So before we understand QUIC, let's understand TCP. TCP provides reliability in data transfer, flow control using sliding window, and congestion control using algorithms like Reno and QUIC. So, however, TCP has three major problems in modern networks. First of all, it requires a three-way handshake for establishment, and then it requires TLS for security, which adds additional round trips. And thirdly, TCP suffers from head-of-line blocking, where a single lost packet can stall the entire data stream. Now, HTTP2 runs over TCP. Even though HTTP2 provides multiplexing, packet loss still blocks all streams because TCP delivers data in an order. This becomes a major issue for mobile networks, high latency links, or real-time applications. Now, let us understand this. So QUIC stands for Quick UDP Internet Connections. So instead of building on TCP, QUIC runs on top of UDP. This is an important design decision. So at first glance, UDP might seem unreliable, but QUIC implements reliability, congestion control, and security at the application layer rather than relying on the operating system's TCP stack. So the key idea is to re-implement TCP-like features using QUIC, but in a more flexible and efficient manner. So now it has been standardized by the IETF as a transport protocol and is no longer Google specific. So the key features of QUIC are faster connection and security, Offline blocking is eliminated and it provides congestion control better than TCP and connection migration. So, first of all, QUIC combines transport handshake and cryptographic handshake. So this allows 0 RTT or 1 RTT, which is round trip time connection setup, compared to a TCP or plus TLS, which may require multiple round trips. Hence, it is faster and it also reduces latency, especially for repeated connections. Now, QUIC also offers built-in security. Unlike TCP, encryption is mandatory in QUIC. So QUIC integrates TLS 1.3 directly into the protocol, which ensures no unencrypted headers, protection against packet injection, and better privacy. Now it also eliminates head-of-line blocking. So like in TCP, the data is transferred in one data stream. QUIC's multiplexing surpasses that of HTTP2, and there is no sequential dependency between each stream on a single connection. That means that if there are three streams and stream 2 loses one data packet, then it only affects the processing of stream 2 and does not block the data transmission for stream 1 and 3. So, for example, there are three streams and data transfers like this. So if a data packet is lost, let's say data packet 5 is lost, so it will only affect the data processing of stream 2, whereas stream 1 and 3 will be running as usual. So it also provides improved congestion control. So QUIC supports modern congestion control algorithms such as BBR, which stands for bottleneck, bandwidth, and RTT. This is predictive and not reactive like TLP, that is tail loss probe. Since it runs in user space, these algorithms can be updated without any change in the OS kernel. Now, the fifth point is connection migration. So, quick connections are identified by connection IDs and not by IP addresses. So, what this does is that it allows the connection to survive network changes and things like Wi-Fi to mobile data switching. This is useful for mobile devices mainly. Now, HTTP3 and its evolution from QUIC or its relation with QUIC. So HTTP3 is not a modification of normal HTTP semantics. Instead, it is a change in the underlying transport protocol. For example, HTTP 1.1 used TCP, 2 also used TCP, whereas HTTP 3 uses QUIC. Since QUIC already provides multiplexing, encryption, and congestion control, HTTP3 becomes faster, more resilient, and better suited for modern web traffic. It is already used in several productions such as Google Search, YouTube, and Cloudflare. So now comparison between TCP and QUIC. So first of all, connection establishment. In TCP, handshaking is required, a three-way handshake, whereas in QUIC it needs only 0 to 1 RTT. Encryption in TCP is optional. It can function without encryption, whereas for QUIC it is mandatory and therefore offers a higher degree of security. Head-of-line blocking is present in TCP, whereas QUIC eliminates this as it allows multiple data streams and data packets are not transferred in a specific order. So loss in one data packet allows the other streams to function without any blockage. Now mobility support is not provided in TCP, whereas it is provided in QUIC as it allows connection migration. Now the connection is dependent on connection IDs, not on IP addresses. Now OS dependency, the TCP is dependent upon the kernel, whereas QUIC is dependent upon user space. This means that QUIC is based on application layer and therefore can be updated instead of changing the entire kernel like in the case of TCP. Deployment speed of TCP is obviously. Now when it comes to deployment speed, TCP is slower whereas QUIC is fast. We can explain this by looking at this diagram. So when HTTPS runs over TCP and TLS, we can see it requires several round trips for transmission of data, whereas in case of QUIC, it only requires 0 or 1 round trip. This obviously gives it a boost in the case of QUIC in terms of speed. So by summarizing, we can say that QUIC runs over UDP and it provides reliability, congestion control, and security into user space. QUIC solves many limitations of traditional TCP. HTTP3 built on top of QUIC enables faster and more reliable web communication, especially for mobile and real-time applications. So we can say that QUIC and HTTP3 are excellent examples of how classical networking concepts evolved to meet modern internet demands while still being rooted in the principles that are taught in computer networks. Thank you.